Thank you all for attending this webinar today, spending most of your lunch hour with me here. My name is Kiefer Paulson. I'm a visualization specialist. I've been with CTC for about 2 years now, doing a lot of architecture visualization stuff, working with virtual reality and HoloLens and 3D printing as well. And I'm very excited today to be presenting to you Maya for visualization and how you can get your Revit project into Maya for these projects. Sort of to preface this webinar, this is geared towards very novice Maya users, maybe people who've never opened a program or never really done anything. They've heard about it but haven't utilized it. So a lot of this stuff is going to be very, very beginner level material. So without further ado, let's go ahead and get right into it. So a lot of you might be thinking, why Maya? You may have heard that it's part of the entertainment creation suites. Why would we need to go that far with our Revit project? And to answer that, it's just a few bullet points here. It's a very widely standard tool. To describe Maya for somebody who has maybe never heard of it, Maya is essentially Revit for the entertainment creation suite. When you get the AEC collection, you get your Revit and your AutoCAD. That's kind of your meat and potatoes of the suite. And the same thing with Maya and the entertainment creation suite. It's the spearhead software, right? If you get in the entertainment creation suite, you got to know Maya. Just like if you get the AEC collection, you got to know Revit. We can see with the list here that has a lot of applications. These are all projects that just quick Google search showed that they used Maya in at least a part of their production pipeline. So everything from live action stuff here, Silent Hill and Salt, if you need to model, texture, render something and then composite it later with your live action shots, Maya is very good at doing that. As well as full-length animated films, there's a lot of fur effects going on in Alpha and Omega here, particle effects going on in Monsters vs. Aliens, very complex face rigs for characters or people that might have facial deformation, stuff like that. Maya can handle all that. And as well as connecting to game engines like Unity, Unreal, and Autodesk Stingray. It communicates with those programs very well, so you can see Halo 4 and Witcher 3 here, a couple of projects that use Maya. And it's kind of where I can see that the industry is going. All right, so the industry, a lot of times at CTC will hear the argument of, I want things to look as beautiful as possible, but I don't want to spend a lot of time on it, right? The pretty versus the impatient. And Maya is sort of an answer to that, as very intuitive, very fluid controls you can get from object 1 to object 2 and make these really small, subtle changes very easily. And then if you're going to be developing anything on the Microsoft HoloLens, which if you haven't seen it already, that is going to be the future of technology. It's a little rough around the edges right now, but it's definitely going to be like the next television set. These holograms are going to be all over the place. And currently the only way to develop anything on the HoloLens is to use Unity. And Maya obviously communicates with Unity very well. So also, the Arnold renderer. If maybe a couple of low-budget films here that maybe you've heard of, maybe you haven't, Iron Man 3, Guardians of the Galaxy, Logan, those all use the Arnold renderer, and it is default now with Maya 2017. How Arnold is capable of making these beautiful images is with these physically based materials, which it can be kind of hard to describe to somebody who may not know the difference between digital and physically based materials. But it allows you to get to like the most realistic possible images because it uses attributes that are defined by math and science to create objects that react to light and to physics and things in the most natural way possible. It's a lot of, really high level physics, stuff like that hard to describe, but it just allows you to get to these really, really, really realistic materials. So to outline the demonstration here, we're going to export an FBX from Revit, which is a pretty simple process. I'm not going to dive too much into it, but if you do need to know more, we do have about a 40-minute long YouTube video on our channel that talks about just that process. Importing the model into Maya. Again, very standard process. We are going to check one checkbox for this workflow that'll save us some time. Just a brief overview of working inside of Maya. So it's kind of the biggest hurdle to jump for people who are opening the program for the first time without professional level education. That there's so many things that you can do. There's so many buttons. There's so many icons. There's so many things that can happen. It's just it's very easy to get lost right away. So just a very brief overview of just dividing these sections into bite-sized chunks. And then we'll go over assigning materials inside of Maya. Now this is the major drawback to going from Revit to Maya or Revit to 3ds Max or anything, is that it's really hard to get your materials that you made in Revit to translate to these other programs. There are some third-party plugins that I haven't had the time or resources to mess around with, like Matte Converter is one. It'll convert your Revit architecture material library to the sort of Maya entertainment creation material library. But I haven't had time to utilize those, so I can't speak for their efficacy. So, but yeah, it's kind of the drawbacks. You have to reassign your materials, but inside of Maya, I'll show you how to make them faster, how to organize them better, and how to just make them look better than Revit arguably possibly could. And then we'll really briefly go over physics-based object, some cloth that reacts to wind the way cloth should be, just how easy it is to create an object like that and have it to react the way you want it to. It's super simple inside of Maya. And then we'll touch very briefly on batch rendering for video. I have a feeling maybe some of you might not know what that process looks like or how animations are created, so we'll just quickly go over what a batch render would look like. So we'll get right into the demonstration here. You will see we'll pop right into Revit here. So this is just a free open source model that I found. It's a small house, small file size that for exporting live for this video here. There was a few objects that I had turned on before, like the entourage. If we turn that back on, there's some cars and trees and things like that. But if we go up to the top here, the export FBX, you'll see that it saves the 3D view as an FBX file. So what that means is anything you see in your scene here will be exported in the 3D view. So all you need to do, and for this demonstration I'm going to be doing an interior rendering, so to reduce the file size and to kind of save some time, I just went to the visibility overrides, and that's why I had the entourage turned off, just to reduce the file size and make things as easy as possible when I actually do click export. I'm not going to save. And we will navigate to my project here, and we'll just overwrite this one. We'll call it 3. And boom, it's exported. So then we'll go right into Maya. So this is Autodesk Maya. So you'll see in here we have our workspace. Everything that you import for your 3D objects, if you create it, it's all going to be in this little workspace here. It's very easy to tumble around, to zoom in and out, to get to where you need to be, pan around. It's very fluid controls. So before I just go to File and import that object, I'm going to first show you guys what the project window is all about. So how Maya works with linking all these things together. Obviously, 3D projects get to be very large scale things, a lot of files floating around, and it's easy to lose some of that stuff. How Maya organizes all that is through the project window. Now you see here I already have my current project, the Revit to Maya demonstration. But if I were to click new, it would just create a new project for me, and all a project is a hierarchy of folders, right? So if I were to show you what mine looks like, the Revit to Maya, it's just this guy here, and it's just a big hierarchy of folders. And if I were to take this home with me, copy it, and open it at Maya at home, everything would still link together correctly as long as these folders remain the same name and everything. And you can work off of the network as well, so people can work on the same project at the same time and then kick those updates back and forth, as long as that folder structure remains the same when you set your project window. So I'm not going to make a new project because I've already set mine up in here. And now I'm just going to File, Import. And we'll see here there's a lot of different file types that Maya is capable of importing. There's IGS, DWG, even Illustrator files. You can turn your vector graphics into 3D files, and then the default Maya ASCII and binary. So I'm going to go up to that 3D view that I exported earlier, and the only thing I'm going to make sure to check is this Remove Duplicate Shading Networks. And normally this is turned off by default, but we want to turn it on because Revit is going to try and kick out all those materials in the FBX file, and Maya is just going to read those all as just basic white materials with really, really long names, and it can really impede your import process. So just remove duplicate shading networks there. So I'm going to go ahead and import that 3D view, and we'll see an error about vertices that are overlapping. That's fine, it'll automatically clean that stuff up. And we have our 3D model here of our house. And you can see I can click on these things, I can get to the sub-object level, clicking on a face, and I can move it around if I want to. I can extrude that face if I'd like to, anything like that. That's basic, modeling 101 inside of Maya here. So really quickly, I'm just going to get inside the interior here. And this was kind of the shot I'm trying to render off, right? This little kitchen area here. And I'm going to, select this shelf. We'll focus on it so we can focus on our view. And I'm just going to right click and go to Assign New Material. And if we scroll down to the bottom, we get the Arnold Standard material, the AIS. And if we get to the component attributes for material attribute. So we'll see the material attributes for the Arnold's materials. You got your basic, color. We can select this and map it to a texture if we would like to. The specularity, and as well as like the weight of how much you want that thing to show specular color. Reflections and refractions for when light passes through it. If it was a glass object, you'd want it to refract light. And the index of refraction is also, you can set that to be an exact number. One really useful thing and I realize this doing this project is very handy, when you want to assign textures to your materials. Let's say you want to borrow the Revit material library, but as you all know, the Revit materials are buried deep inside of your computer, deep in the C drive. It's kind of a pain to navigate to. But with this really quickly, we can go back inside of Revit here. If we go select a material that has a texture, like this bed frame here, and you just select the texture like you're going to change it as you would normally in Revit. Instead, we're going to go up one level so that we get to the actual maps folder here. I'm going to right click on it and hit open, and then it brings the actual, an actual window of the material library that Revit has, and you can see it's buried in your C drive, common Autodesk shared material textures 1 maps. It's hard to get to nav quickly, but right away with just a couple clicks here, it's a little hack. And what we can do with this folder now is we can directly copy this to our source images in our Maya project, right? I can just copy, I don't want to move it, but I can just Control-C, Control-V, and then I will instantly have every material or every texture that Revit has available in my Maya project. So that's a pretty useful little trick. So after we decide on our textures and we create these materials and we start running some test renders, we're going to get to a scene that looks a little like this. You can see I created some light sources here. The objects all have textures on them, and this is just the default working viewport inside of Maya here, so it doesn't look as beautiful as it could. But we're going to open up the Arnold render view here. And the Arnold render view will start to display, and it'll start swirling out and enhancing this image. Right now I have my samples turned down really low, so this image, it's not going to get much better. But it's really quick and really useful and really powerful because it gives me an idea of what that rendered image is going to look like. So we can see we have this orange light coming through the window, and it's going on the table here, which I can actually click on the table and it updates my selection here as well in the workspace. Really nice. And if I say I wanted to change the angle of that light, I could just change the directional light, and then it'll automatically update here in the Arnold render view, so I can see if that light is the angle that I'm looking for or not. So after a while, I was playing with the render settings, and I came up to an image that's looks kind of like this. You can see if we zoom in, it gets pretty noisy here. If I increase the sample count, or the amount of sampling done in this render, it could have reduced some of that noise. But you can see the Arnold is really, really good at these actual physical materials. So this glass looks very much like glass, and I was able to create that material in just a matter of a few clicks. And you can see that it refracts the light, in a very realistic way. And it looks very good on the whole. So if we go up to the render settings really quick, and a lot of this, this is getting a little deep into it, but you'll see in the frame animation here, it's saying that we're only rendering off a single frame. If I change that to name number extension, it now allows me to set a frame range for the total rendering. So I set it here from 1 to 200, and if I went to render and batch render, it would create a batch render job to kick off all those still images. And and I just realized that we didn't really cover some of these icons and stuff up here. So up top you'll see you have your basic file your menu bar, sorry, with your file, edit, create, stuff like that. And also down below we have a pull down window, and these are kind of the subcategories that Maya really excels in. So there's modeling, rigging, and animation. Rigging is creating a skeleton for your animation mesh. So rigging and animation, particle effects and fluid effects, cloth effects, anything like that is handled in effects, and rendering as well. So, and you'll notice that when I click on one of these things, it changes some of the top buttons up here. So if I switch to FX, you'll see you have end cloth, end hair, constraint, things like that. Rigging also has its own. So it's just another way to, and you can change these with just a touch of a button. It's another way to really maximize your workflow. And down here you see we have the shelf. A lot of you are familiar with shelves. These are all icons, and they all do things. Once you know what you're trying to do, it's just another way to do it. The attribute editor here, as you can see, shows more in-depth attributes to whatever object you have selected in your scene, as well as the channel box. Now the channel box, this is really interesting. All these different channels here are directly keyable, meaning I can set a key on it on frame 1, change it to frame 40, and set the key on my translate Y, and that's what would create animation, is going from frame 1 to frame 40 and setting keys on these attributes here. So anything that you click on here, all these attributes are directly keyable for animation. So really quick, we'll do a physics-based object. Let's say I wanted to have a curtain over this window. And I'll just start a new scene here. I'll actually open my curtain scene to sort of declutter some of this stuff. We'll open the curtain. And these are just sort of basic objects that I really quickly model up. Just a plane, a bar up top, and an object with a lot of vertices and polygons on it to allow for this physics stuff. So right now, if I were to click play, nothing's going to happen because I haven't set anything up. But really quickly, I'm just going to show, if I go to end cloth, we'll tear off this window here. I'll go create end cloth, and I'll select this guy, create passive collider, again, create passive collider on this. So now if I were to click play, you'll see that this now reacts like cloth, but it's not attached to the bar yet. And you can see that the objects that we defined as passive colliders are now going to act as collision objects for that cloth shape. So you can see now the cloth will fall down, it'll bounce off of this little guy, and that's all well and good. So if we wanted to attach this, I'm going to press 4 to switch to wireframe mode. I'm going to select just the top ridge of vertices here, nice and sloppy selection, and then I'm going to select this crossbar, which I already defined as the rigid body. I'm going to select this crossbar, and I'm just going to go end constraint, point to surface. And now I'll hit 5 to go back to default view, and now we'll see that that cloth is attached at that bar by the point of those vertices that I grabbed. And you can see it actually looks more like a curtain now. It's dangling in the wind, if you can see that at all. And there's also a lot of attributes that we can edit, as far as including the strength drop off here. Let's get to the nucleus here. Yeah, the nucleus, you can actually tell it that, gravity right now is set to 9.8, which is standard, Earth gravity. We can change that to, 0. We can go -1 if we wanted to. And now if we click play, this is actually going to float upwards because gravity is going in reverse. You can airspeed, which direction it's going, all kinds of stuff. You can just really fine-tune this cloth to react and do everything that you want it to do. So now let's pretend that I've reached a point. I'm happy with this simulation. I now have an animation that I want to render off. So we go back to that batch rendering that I showed you about. We did a render batch render, and in this scene I already set up multiple frames, name number.extension. And if I were to click the batch render, which I'm not going to do right now, we're starting to run a little low on time. But if I were to click batch render, it would kick off a bunch of these images. And these are all just still images rendered one at a time, that when you play it back at 24, 30, 60 frames a second, that's how you get your animation. So this cloth here, just really default render job here. It's not beautiful, but you can see what batch rendering is and how it works. And that's basically how animations are created. It's how all movies are made. It's rendered one frame at a time.